So observe very carefully. So till now, last class we studied how the things will be present like solids, liquids, and gases. How to demonstrate what is the characteristics of properties. That is what how the properties like how the molecules are present, and how to prove that different activities we have done to prove the characteristics of particles of matter. That is what particulate of matter. So now in our today's class, we are going to start the next concept that is only called as states of matter. So already I taught you we are having a 5 states of matter, but in that 3 states of matter only it will be present or existed at normal conditions. So under the normal conditions, if you have taken like normal temperature, pressure, and everything, at normal conditions, if you have observed very carefully, so we are having a matter can exist only in 3 forms. Matter can exist in only 3 states. So that is what we all people knows. What is the 3 states? All of you. First one is solids. Next one is what? Liquids, and last one is gases. So at the normal conditions, these three are the states of matter, which we can find even many examples for solids, many examples for liquids and gases. And remaining 2 states of matter. Can you tell me what is the remaining 2 states of matter? All of you? Plasma
Sir,
state
plasma and
uh,
And
plasma BEC.
Bose-Einstein condensate.
Bose-Einstein condensate. So these two are the things. Of course, plasma is also existed in the atmosphere also and out of the atmosphere. Out of the atmosphere, most of the substances present is plasma only, gas. Between the stars and all, interstellar stars and all, the gas which is present is actually a plasma only. So now, and BEC, Bose-Einstein condensate. So this one actually which is extremely present at low temperatures or high temperatures? Extremely present at the low temperatures. Yes or no? I have taught you already. Correct or not? So which
Yes,
is extremely present
low
at low
temperature.
temperatures. So which is actually created by Bose Einstein. Actually Bose, Satyendranath Bose. He is our Indian scientist. He is actually after his invention, he has been posted his theory. That is what the entire project to the Einstein, and Einstein is also accepted it. That is what it has been published after approval of Einstein. That is why even that is called as Bose-Einstein condensate. What was to call? Bose-Einstein condensate. Understand everybody? So forget about that all the things. Plasma and Bose-Einstein condensate which does not have any importance now. So only we are going to study at normal conditions. We have only 3 states of matter. So that is what matter can exist in 3 states in the form of solids, liquids, and gases. So let us see how we can decide what is the state of matter. Who is deciding, sir? Who is this normal conditions? So that is what we are discussing now. So factors deciding the states of matter. States of matter. So all of you make it. Factors deciding the states of matter. So can you tell me what is the first factor which all people experience it? States of matter will be decided.
Size.
Yes, please. No. Any other?
Sir,
Common?
space between them.
No, that is a bigger, of
The
course.
shape.
It is also, it's not that shape. Any other? Who will decide either it
The
will?
temperature.
Yes. Shivani is correct. So temperature. So temperature is the main thing which will decide our states of a matter. So either the given matter is a solid or liquid or gas will be decided by the temperature of a substance. So if you notice the temperature, as we all know, temperature increases, something is increases. We all studied in the yesterday's class. Everybody, you people,
Kinetic energy.
very good. So as the temperature increases, all of you remember, temperature increases, understanding? The kinetic energy of the particles increases. Kinetic energy of the particles increases. So as we all know, if the kinetic energy increases, then what will happen? All of you, the particles will changes from increases, and immediately what will happen? Solids will converting into what? Solid matter may converting into,
Liquid matter.
may change into, understanding? May change into liquid, and liquid may change into what? All of you.
Gas. Gas.
Liquid may change
Into
to
yes.
gaseous state. Understand? So that is what it will be happening. So that is the basic thing which is happening. So now, same way, if you are doing the reverse process, we all notice that if the temperature decreases, if temperature
The kinetic
decreases,
energy
yeah. So again, reverse process will take place. What will happen? All of you,
decreases.
yeah,
Kinetic energy.
gaseous state which will come back to the what? Liquid state. That liquid state again come back to the what? If the too much temperature is decreases. Everyone, what will happen?
Solid.
Yes,
Solid.
solids it will form. So if you take the examples, so we all know first increasing temperature. If I take the ice, we're having ice. So ice, what is the state actually? Solid state. So if I'm heating means even if I put normal outside the fridge, outside the refrigerator, so automatically it will be converting into what? Everybody, water. That is what we used to called as liquid. And further, if I am heating, we all knows if I'm heating further, it will be converting into what? All of you. It will be converting into, please respond, water vapor. So that is only we used to called as water vapor, also called as what? Steam. Is it right or wrong? All of you. So that is what you have to
Yes,
remember.
sir.
Now, if I make the reverse process, we are all very familiar by cooling. So by cooling, water vapor will be converting into what? All of you, even class 6th and all, you will do that activity, cooling. And again, further, if I am cooling, that is what? It will turns into what? All of you. Again, water will turns into what? Ice. Is it right or wrong? Yes, please. Respond, guys. That is what.
Yes, sir. Yes, sir.
First parameter who will decide the states of a matter. First factor. Next, second factor. Anybody can tell without this?
Yes, sir.
Yes, please. Very important one. So what is the second parameter, everybody? It is the pressure. Okay. So now, after this, I'm going to change your mind, like your answer of boiling point of water. So after this explanation. So let us observe very carefully. Change in pressure can change also the state of matter. Sir, how, sir? Let us see. If it is high pressure, all of you remember, if it is high pressure with
Sir, like dry ice, dry
yes,
ice.
yes. If it is a high pressure by with decreasing temperature, then the gaseous particles will come closer to each other, and you can see they will changes into liquid as well as they will changes into solids also. So that is what it will be happening. Or else you can see the solid can be converted if by pressurizing, solid can be converting into liquid, and liquid by lowering down the pressure, also by increasing the temperature. Also you can see conversion of states in terms of pressure. If you notice it, I may increase the pressure by decreasing the temperature, so gases may converting into liquids or solids. And I am decreasing the pressure. Understanding, everybody? So if I changes into like increasing temperature, decreasing the pressure by increasing the temperature, so then the solids can be converting into, okay, liquids by decreasing the pressure and increasing the temperature. Same way, if you see, temperature also plays important role in conversion of states, and you can notice it, all of you. And pressure is also will be helpful for us to conversion of solid to liquid or gas to liquid or whatever it is. So that is why you remember, and the pressure is also the main important parameter which will decide the states of matter. So why, sir, and what, sir, how, sir? Let us discuss it now. So all of you remember, if I increase the pressure, so you have to remember change in pressure will change the what? All of you. Yes, please.
State of matter into liquid or
Change in
into,
pressure can change the
sir, it will convert it into solid only, no, sir.
solid means some substances liquid. Clear, Amari? Further,
Sir.
if I'm increasing the pressure, that is what, Mari. Further, if I'm increasing the pressure, then liquid will changes into what, guys? Everybody, gas. Clear, Amari?
Yes,
Yes,
sir.
please. That is what. So change in pressure can change the state of matter. So first thing, so let me take gas now. So if I'm keep on increasing the pressure, all of you observe, it will be converting into what? Liquid. Clear? Again, I'm keep on increasing the pressure. It will be converting into what? Please respond. Solid. Clear?
Solid.
That is what. So increase in pressure. So I'm increasing the pressure. Increase in pressure. So pressure is increasing in the sense of somebody should be decreased. What is that? Everybody.
Temperature.
Yes. With decrease in temperature. That is what is expecting from all everybody. So pressure is increasing means what is decreasing, Amma? With decrease. With decrease in what? Decrease in temperature. Clear,
Temperature.
everybody? Now, same way here again, I will further increase the pressure. Increase in pressure. If I notice a, so but here also I should decrease what? With decrease in
Temperature.
decrease in temperature. Okay, so that is what you have to remember. So gas will convert into liquid, liquid will convert into solid. Again, reverse process if you have taken. So reverse process, what will happen? Everybody, decrease in
Decrease
pressure.
in
Yeah.
temperature.
No,
Increase
decrease
the
in pressure.
pressure.
Decrease in pressure and increase in what, Mari?
Increasing
Yeah.
temperature. Temperature.
Increasing temperature. Clear? Everybody understood, Amma, Shivani, Alfin? And here also further, if I decrease the pressure, decrease in pressure and increase in what? Temperature. Okay, so that is what you have to remember. Now, if you notice it, as I'm saying, formation of liquid to solid, if you observe very carefully, you can see everywhere pressure and temperature both will plays important role in conversion of states. That is what we are understanding. Is it right or wrong? All of you, please respond. But if you take here ice is an exceptional solid which is converted into liquid on high pressures. All of you remember that. Clear, everybody? So basically, which is actually converted the liquid on very, very high pressure, but by the time temperature should be decreases. So you can take here, all of you, basically ice is an exceptional solid which will be converted. You can notice it. We have to be pressurized more, not decrease in pressure. You can see everything like formation of ice. So we are having a water vapor. If I keep on increasing the pressure, so what will happen? Temperature is decreasing. It will be converting into what? All of you, liquid.
Liquid.
And again, further, if I am keep on decreasing the temperature and pressure is increasing, so what will happen? It will be taking place into the,
So one doubt, sir.
yes, Mari.
So when we are decreasing the temperature, it will become like -4. Like that, it will go, no, sir.
Yeah, temperature, of course.
Then how, sir, that gas is in water vapor, sir?
Which one?
That gas in the gas, it's in the form of water vapor, sir.
Gas is in the form of water. If you take the water,
Sir, if in the
water.
solid, it's sir, if in the solid, it's ice, sir. We are taking the substance as ice. When
Yeah.
we decrease the pressure,
Yeah.
then the increases in temperature, no, sir.
Yes.
So that it melts and it becomes into a liquid, sir.
It will becomes into liquid because they will get the increase in temperature causes to kinetic energy increases. So particles will move far each
Yes,
other.
sir.
So that's what it will convert into liquid. Clear?
Yes, sir.
That is what. So now, so of course, this pressure, now you can see that. So as I am saying the pressure, our atmosphere is exerting the pressure. So that is what the air which is around us is exerting the pressure. So that pressure only we used to call something. Anybody can tell me? We all people studied, I think, lower classes also. Yes, please. The pressure exerted. atmosphere.
Atmospheric
The
pressure.
pressure, yes, yes. The pressure exerted by the air around us. Air around us is called atmospheric pressure. Yeah, please mute somebody who is at atmospheric pressure. Understand, Mr. Kishore? Now you tell me, is this pressure is same throughout the atmosphere or it is varies from place to place? Definitely. It will be varies from place to place, slight variations. Understanding? So these pressure is changes from place to place, but it's not much differences. Slight variations will be there. So the pressure decreases based upon, sir, how it will be. All of you remember, but basically atmospheric pressure, when I am a surface, for example, let me consider Mr. Sanjay is standing on the surface of the earth. This is the surface of the earth. Understand, Mr. Sanjay? So if you notice it here, at this level, the atmospheric pressure, all of you remember, what is that? Atmospheric pressure. Clear, everybody? So atmospheric pressure, which is equals to 1.01 into 10 power 5 pascals. So that is what is the atmospheric pressure, where when Mr. Sanjay is at the surface. Now, if you notice it, as I am saying, is this pressure is same or changes? All of you. This pressure is changes from place to place. Changes from place to place. Sir, how, sir? It is decreasing or increasing? Let us discuss. Now, Mr. Sanjay started climbing a mountain, a big mountain. So let us take it. So he is climbing the mountain. So he started rising upward direction. So if you are all going upward direction, all of you remember, altitude is increasing or decreasing? Altitude, all of you, please respond.
Increasing,
Increasing.
increasing.
So increases
Increases.
increases in altitude, increases in altitude, that is
Sir,
what height.
decreases in temperature, no, sir.
Yes, yes, all of you observe. Yeah, so if the altitude is increasing, all of you remember, the pressure decreases. Okay, pressure decreases. Sir, why, sir? You might be asked me, because air density decreasing. What will happen, everybody? Air density
Sir,
decreasing.
one doubt, sir.
Yes.
Sir, when we go up, like climbs up, the temperature will be decreases, no, sir.
Yeah, Mari. Temperature also decreases. Pressure also
Then
decreases.
temperature decreases, pressure will increase only, no, sir.
No, both temperature and pressure basically they will be directly proportional to each other. Understand? Even according to the Boyle's law, pressure and temperature both are directly proportional to each other. Clear?
Sir, then why, sir, when you're converting into gas into liquid,
By the time we are
increase in
decreasing,
pressure?
we are decreasing, Mari. We are manually doing. You understand?
Yes, sir.
Yeah, that is what you have to do it. Okay. So even normally also, if the pressure is keep on decreasing, means temperature almost it will be fall down. Then only it will be conversion will take place. But most of the cases, even temperature is directly proportional to pressure. If the pressure is automatically increases, now you can see humidity. If you take the humidity, yesterday is a very humid, and of course today also humid air. The air is having very high density. So if very high density in the sense of means more moisture is present. More moisture means you will feel like more pressure, like a suffocation. Have you noticed it? Suffocation means automatically more sweating will come. You feel like more temperature is very high, like that. Yes or no? The same thing will happen. Clear? So when we are keep on going up high altitude, all of you remember pressure decreases because what is happening? Air density. Yes, please respond. Air density decreasing. Understanding? But if you comes to the coastal areas, how many of you know coastal areas? Coastal areas means the sea areas. Understanding? So if you notice the coastal areas, tell me, pressure is high or low? I want to know. Pressure is high. Why, guys? Because atmosphere contains what? More humid. Understanding? Humidity is high. So that is why at the coastal areas very high pressure, and high altitudes like mountains, above the mountains, low pressure or high pressure? Please respond. Low pressure. Understanding? So that is what. So if the altitude is increasing, atmospheric pressure is decreases. If you are coming downwards towards the coastal areas or surface, At the surface, it will be having maximum pressure. Lingesh is asking, the pressure, can I write it as a 101 into 10 power, where I have written here, 101 into 10 power 3 pascals. Even if you don't want to write this all, directly you can write all of you 10 power 5 pascals. That is the answer. Okay. So atmospheric pressure is how much, guys? Atmospheric pressure, please respond. 10 power 5 pascals. That's
10 power 5
okay. Simply you can say that. Okay. But exactly if you want, you can write this one. Or even more perfect value if you want. 101 325 pascals. Is it okay, Lingesh? 101 325 pascals. That is the more even efficient value, approximate value of atmospheric pressure. Okay. So this is what. Now we are using a device to measure this atmospheric pressure. Anyone having any idea? 8th class, those who study.
Barometer. Barometer.
Yeah, 8th class I have taught you. Is yes or no? First chapter we studied. Correct?
Yes, sir.
Yeah, that is. So the instrument used to measure the atmospheric pressure. Atmospheric pressure is called, what is to call? Everybody?
Barometer.
Okay. Barometer. That is what you have to remember. And what is the SI unit of pressure? Mr. Sanjay, Lingesh, SI unit of pressure. It is there.
Pascal.
Yeah.
Pascal.
SI unit of
Pascal.
pressure. SI unit of pressure is Pascal. Okay. So PASCAL, Pascal. So what is the one atmospheric pressure? 101 325. Yeah, yes.
The 10 power 5, sir.
10
In
power,
round.
yeah, ground 10 power 5 pascals. Yes, Sanjay, barometer is made up of mercury only. Please, all of you remember. Okay, mercury, that is called as mercury barometer. We can say it is. Is it clear, everybody? So that is what you have to remember. Any doubt? All of you? So this is the second parameter. Factors deciding the states of matter. First one is temperature. Second one is pressure. And third one is, which some people I heard it in the beginning. Can you tell me what is the third parameter? Interparticulate. What is that?
Space.
Interparticle space.
Interparticle.
Yeah,
Particle space.
interparticle space. So interparticle space, this is not a new thing for us. We are already very familiar with that. So who is having maximum space? Actually, all of you,
Yes.
gas.
Gas.
Who is having minimum space? Solids.
Solid.
In solids, the things are very, very close. And in gases, the particles are very, very far each other. So that is what you have to write it. So write. The states of matter also depends on, Mr. Kishore, can you able to understand? Sangamitra, right. So states of matter, no response at all. Sangamitra and Kishore and all. Also depend upon interparticle space. Interparticle space. Solids have least interparticle space because solids are closely packed or loosely packed. Everybody.
Closely packed.
Understanding? Yeah, interparticle space. Solids have closed interparticle space. Liquids have more than solids or less than solids? All of you. More than solids.
More
Less
than
than. Less than, not
more
more than. Understanding? Liquids have more than, more interparticle space than solids. And finally, who is having maximum? All of you.
gas.
Gases have maximum interparticle space.
Interparticle space.
Maximum interparticle space. Okay, that is what you have to remember. So if I take the solid, so let me take one container. If I take the solid, so how the particles will be? All of you.
Closely packed.
Yeah. Closely packed.
Closely packed.
So if it is closely packed, we can say it is a solid or liquid. We used to say it is solid. If I take the liquid, so particles are having more interparticle space than whom?
Solid.
Solid.
Okay. So that is what we used to say liquids.
Liquid.
Okay, next gases. So gases we all know. Always gases should be placed in which container? Closed container. Understanding?
Closed container.
Yeah. So they are having more spaces between them. So that is what is happening. So please mark it. So this is what it is. So example if you have taken. So this is you want example you can take. This is ice. This is liquid water and this is a steam, water vapor, or we can say steam. Is it okay, everybody? Clear? Understood? All of you? Yes or no?
Yes, sir.
That is what. So this
Yes,
is the
sir.
third factor deciding the states of matter. Okay? Yes. Clear? That is what. Next one is fourth one. Force of attraction. We are also very familiar. So who is having strong force of attraction? All of you.
Solid.
Yesterday only
Solid.
I taught you.
Solid.
Yes.
Solid.
Yes.
Solid.
Solid.
Because solids they are very closer. Understanding? The force of attraction among the particles. The force of attraction among the particles. Now you tell me. So we know that every particle is made up of something. Can you tell me what is that? Every particle is made up of
Atom.
atoms, molecules, or it may be ions.
Moles.
So if you notice it, these particles are held together through a force which is called as interparticle force, or we can say intermolecular force, or we can say intermolecular force, basically we say, or interparticle space. So this force will decide the state of matter. If the force is very high, then the particles will be closer. So and the force is less, the particles will be little bit far each other. If the force is too much low, almost negligible force of attraction, then that is only called as what we used to call, everybody. Yes, please. What we used to call gases. Understanding? The force of attraction is extremely low, negligible force of attraction. That is why particles of a gas very far each other or very closer to each other. Everybody, please respond.
Far each other.
Far
Far
each other.
to each
That is what
other.
you have to remember. So all of you write the force of attraction. Right. First you write the neatly. All of you. Every matter is made up of particles. Every matter is made up of particles which may be atoms, molecules, or ions. These particles are held together. These particles are held together through a force, which is called what is to call, all of you, interparticle force. Is it okay, everybody? Or also we can say intermolecular forces. Intermolecular force. So can you tell me? So who is having greater force, everybody? All of you. Closer.
Solid.
Understanding? If the particles
Solid.
are closer to each other, then the force of attraction will be higher or lower. Everybody.
Strong force of
High.
attraction, sir.
Yeah.
So that low
Yes.
kinetic energy.
Very good. So the particles are closer, to each other, Please mute. Who is that? The force, Lakshya. Ma Lakshya, you have to be rectify that mistake. Why the sound is that? So the force of attraction will be greater or lesser, ma? Shivani? The force of attraction. Yes, please.
Greater.
Attraction will be greater and if the particles are far apart, if the particles are far apart, then force of attraction is less or more? Mr. Sanjay, Sam,
Less.
Less.
yeah, the force of attraction will be weaker. Okay, that is what. So please write it. Clear? Completed? Everybody?
Yes, sir.
Yeah. Now, so let us see now. Here, if you understand this one, so before going to make the conclusions, understanding between the intermolecular space and intermolecular force. So we'll make it first. Let me make the conclusion now. First one. So let me take in order of spaces. That is what interstitial spaces of different states of matter. Who is having greater? That in the spaces if you take intermolecular spaces. So who is having greater?
Yes.
Gas.
Gases having that. Solids is less than liquids. Liquids is less than gases. So who is having large intermolecular spaces? All of you?
Yes.
Yeah, that is
Gases.
okay. Next, if you take
So
the
what is
force,
that, sir? And if the particles are
where if the particles are far apart, then the force of attraction will be weaker. Okay, Mari. Then
yes, sir.
force of attraction. So if you have noticed it, force of attraction, okay, among the particles of different states of matter. So who is having large force of everybody force of attraction? Solids is
Solid.
Solids.
having greater force of attraction than gases. Ellame clear? Anybody having any doubt? You can ask me. All of you. That is what you have to remember. Ma, first, if the particles are closer to each other, the force of attraction will be greater. The force of attraction will be greater, and if the particles are far apart, the force of attraction will be weaker. That's all. I will understand now, everybody, how to make it. Any doubt? Anybody can ask me. Solids, liquids, and gases. So intermolecular space is bigger in gases. Intermolecular force of attraction is bigger in liquids. Sorry, gases, solids. Is it right or wrong? Everybody? Yes, please. Please respond.
Yes,
Yes,
sir.
sir.
Yeah.
Yes,
Now,
sir.
even, sir, how much it is? That is what even. So now go back to the physics. Sir, how much force of attraction between the particles? Suppose if I take the solids. Solids particles are very closely or very close or far each other? Very close each other. So liquids
Close.
are little far each other. Understanding? And gases more far each other. Okay, I'm taking in this way. So now if I notice it, how much of this force is present? That is what. So let us go back to the physics gravitation chapter. Of course, we'll study. So according to the physics, if you have noticed it, the force of attraction present between any two particles. Of course, Newton proved that. We people will study also. So all of you remember the force of attraction present between any kind of particles, either may be a solid or liquid or gas, doesn't matter, which is actually directly proportional to the understanding. The force of attraction is directly proportional to the product of their masses. Understanding means mass of that particles, product of their particles, and inversely proportional to the square of distance between them. Understand everyone? Sanjay, Lingesh, everybody, the force of attraction is inversely proportional to, understand everyone, inversely proportional to whom, guys? Inversely proportional to the square of, Lingesh, yeah, please verify it.
Sir, then the force of attraction is
Yeah,
equal to M into M by D
yeah,
square, sir.
square, yes, yes, the force of the inversely proportional to the square of the distance between them. Clear? Formula we'll study it in physics, Mari. Don't worry. Okay. Between two particles. So just I am saying it. Okay. So as it is, force of attraction is greater in solids compared to liquids and gases. So that is depends on particles of mass. Let me take particle one is m and another particle is capital M, and the distance between them is d. So it is a product of directly proportional to product of masses and inversely proportional to square of distance between them. Is it okay, guys? Please respond, all of you. Yes or no? Yes.
Yes, sir.
So that is what.
Yes, sir.
These are the, so this is
Sir.
one of the Newton's, actually. This is Newton's laws. Newton's laws will relate to the clear. So this is only we can call it as Newton's law of gravitation.